So now let's review some of the things we have already learned. This is the overall view of a computer we have seen. So we have assembled a computer and this is how it was looking. So this part is the computer hardware, this bottom one, and the CPU is in the center, and CPU is connected with memory via buses. Remember all the buses we discussed? And it connects to different devices. And on top of the hardware, we have installed the operating system. This is the operating system here. And the operating system has something called kernel. Kernel is nothing but the core operating system. The operating system which directly handle the devices. This tooth wheel kind of boxes you're seeing right here, they are the device drivers. So they are the device drivers to connect with different devices. We have seen that in the device manager, etc. And these are the different programs which is run by the operating system. So these are different programs. So Word, Excel, the Chrome browser, PowerPoint. So the PowerPoint we are doing this presentation right now. All are different programs which is run by the operating system on the hardware. So the operating system has complete control on the life of the program, what it does not do, everything. So operating system manages those programs. These programs are not really part of the operating system, but they are developed by different people for specific purposes. Okay, but it runs on top of the operating system. Let me erase my annotation here and let me explain different relationship between different components.
A question.
Yes.
What are those red dotted lines?
Yes, that's what we're gonna see. What are the red dots? And so there are a couple of lines going on. One is this yellow line and another is this red dots, then this green lines. Yeah, so those are the three things we're gonna discuss. Let me erase it again. So let's take the example of the red one here. Okay, everything, if you look at, everything is going through the CPU. Every line is going through the CPU. And in the case of Explorer or Notepad for that matter, so what it does is it goes through the operating system and then it reaches the CPU. Okay. Then through the CPU, it reaches to the memory. That is the path it follows. And same, for example, if a program like Notepad or any program which is you're familiar with, or Word or Excel, suppose you're accessing Facebook. Whenever you are downloading a file or you are accessing Facebook, you need to access NIC card. Remember the NIC card we were discussing to communicate with the network. So what happens is the Chrome browser will request to the operating system. Okay, so where is Chrome? Yeah, Chrome is here. So suppose you are accessing your Gmail. So it will first access the operating system. Then from the operating system, it goes to memory with the help of CPU. And it also accesses different devices through the operating system. So operating system controls the access of programs, access to different devices. So that is this red arrow is all about. How the control from different programs go through the operating system to different devices and memory. Now let's look at the access of a file, secondary storage. Now, how does a program access secondary storage? That's what this yellow line is about. First, it comes to the CPU, then it goes to the operating system, then it goes to the device driver, and then finally to the disk device. So this line ends in disk, if you look, because the secondary storage is inside the HDD. Remember the HDD we used, HDD as well as SSD. We built the HDD. If you're reading a file, you're accessing a file. Suppose you're uploading a file to somewhere. So this is how the control flows. First, it will come to the CPU, and from the CPU, it goes to the operating system. Operating system accesses the device driver, and then the device driver ultimately connect to the disk for the actual I/O.
Question.
Yeah.
So can it directly get connected to CPU without operating system?
Yes, the answer to that question is yes. A program can execute any instruction it wants. Okay? Good question, by the way. A program can execute any instruction it wants to. Suppose it is executing an instruction which it is not supposed to execute. What will happen is there will be something called an interrupt happens, and interrupt is always handled inside the operating system. Okay. So that is how the operating system controls that program. Okay. So that's how the operating system controls the program, in the sense that the application or the program can execute any instruction it wants. But if it is a straightforward instruction like adding two numbers or moving some memory from some X to Y, it won't. Operating system has no involvement in that. In fact, all the instructions we're going to see today in this presentation, in this chapter 3, operating system will not come into the picture at all. The application is executing safe instructions which will stay inside the memory of the application itself.
So if there's only complicated operation, then operating system comes into picture.
I wouldn't use the word complicated. I would use the word privileged. Yeah. So how do I know an operation is privileged or not? Is based on whether it's going to affect other programs or not. Okay. If Explorer is a program or Notepad is a program which is affecting other programs, then operating system will come into the picture. But if operating system doesn't care, for example, Notepad is adding two numbers, 2 plus 3 equal to 5. Notepad is doing that. Operating system, it doesn't care about that operation. It doesn't matter. Does that answer your question? Yeah. If the application is executing a privileged instruction, operating system comes into the picture. There is also a concept called system calls. I don't want to get into it, but this is a good overview. So this is the overview of how an application, operating system, different hardware, and how different device driver works. So this picture will also show that the device driver, which is also a program, which is not here. Okay. So device driver is a program which is not in this list, but it is somewhere here inside the operating system. Why? Because device drivers are computer programs which can execute privileged instruction. Remember the instruction you were asking? Without the permission of the operating system. So they are part of the operating system itself. So no one is watching over, including the operating system, is watching over the device drivers. Why that is the case? Because device drivers need the device access directly and bridge the gap between operating system and the device. So that's why device driver is inside the operating system and not in the user space. So this is called a user space, and this is called kernel space. Okay. This diagram is true for Linux, Windows, Android, almost all the operating system in the world right now. So this is a common architecture which is being followed, nothing specific to Windows, though most of the programs we are seeing is Windows.
Question.
Yes.
You didn't explain the green line.
Okay. Yep. So sorry about that. You reminded me correctly. So the green line is nothing but how the device drivers access the devices. What I wanted to show is that the operating system is not coming into the picture. If you look, the operating system is not coming into the picture. So device driver is directly going to the CPU and accessing the devices here. Can you see that? Yeah. So that's what I wanted to show you. So device driver is not under the control of operating system in general. When I say control, I mean managed. For example, operating system has no way to stop an instruction which is executed by the device driver. Yeah, if it wants to execute. Yeah. So that is what I wanted to show using the green lines. Good observation. So let's move on. So we have seen this multiple times, the purpose of the operating system. We have seen that in chapter 1. We have seen this in I think we skimmed over this in chapter 2 as well. So again, this is the primary purpose. So this secure programming interface. So all the programs which runs on top of an operating system uses the operating system to access the hardware. Operating system abstracts the hardware and give an interface. So interface is nothing but something like a steering of a car. So the car steering is an interface which will help you to drive hundreds of different small components inside a car, which is the wheel, the front wheel, the back wheel. Then if it is a power steering, there is power coming to that steering and you are not really doing the mechanical work to move the tires, turn the tires. So a lot of those complexity is abstracted from you in a steering. Like that, the operating system provide programming interfaces to make the life easier of the programmer who is writing programs for that operating system. Typical example is accessing a file, accessing network card, accessing a USB device, a lot of those kind of devices. Yeah, so that is programming interfaces. Most of the operating system provide basic functionalities like file system, disk. We have seen that disk doesn't have any file system by itself. That HDD is nothing but a set of sectors at the end of the day, which doesn't have any file or even file system. So the concept of files, which we upload and download, all this is coming from the operating system. In Windows, it is NTFS. In Linux, it is ext, and so many other file systems are there. So that is an example of basic functionalities. Then other functionalities like explorers, notepads, text editors, so on and so forth. We have seen this example. So this is one particular factor. So operating system is nothing but one big program or a set of programs. In fact, it's a set of programs, I would say, set of complicated programs. So this is the purpose of device drivers. So operating system, like we mentioned before, doesn't understand certain devices. It needs additional programs, which is working very closely with the operating system to connect to a device and understand that device, how it works. So we mentioned a lot about files in the previous couple of slides, but we didn't really explain what's a file. So file is a representation of data inside the secondary storage, the HDD. At the end of the day, it's just binary, ones and zeros, one big binary number. And the meaning of that number will depend on the program which uses it. For example, JPEG is an image file, but you need to have a program which understands that image file to open it and show you that image, display that image. So again, it's ones and zeros. A computer program itself is a file stored in the disk. Everything is a file. Operating system itself is a group of files. We will see some of the files of the operating system, Windows operating system. That itself is a file. So now what is not a file? Normally we don't call something which resides in CPU or memory a file. So at least in this presentation, I'm not going to consider. Whenever I say file in this chapter, file means that a entity in secondary storage, the HDD. Or SSD for that matter. Now, this is not a very correct statement. There are other things to consider. In Linux, everything is a file. A process is a file. A program is a file. Network card is a file. Everything is a file, including the devices. So we are not going to discuss that here. Any questions? Right?